Hey all, so today I'm going to be guiding you all on how to do the problems on number 56 on chapter 7. So yeah, so I've done the free body diagram there, and that you can see that there are A, B, C sections. So I'm going to divide this problem into two sections, which is section A, B, and also section B, C to find. So let's go directly to the first section of A, B. Okay, so on this section on AB, I've also joined the FBD. So as you can see there, we have a force acting on point A, and the value of the force we calculate is that it's 0.75, and also we need to know the length between A and B, but at this case we don't know what's the length, so we are going to notate it as X. Okay, so as you can see here, to know where's the shear and moment forces, it's on point B, and that the shear forces noted as V is acting down there on the negative direction, and also the moment is acting on the positive direction. And then we can just directly put it into the Newton calculations, which we can notate sigma, the total of forces on the y-axis is equal to 0. So we can say we can see that we have 0.75 on the positive direction, so it's on the positive form, subtracted by the negative shear forces equal to 0. So we can know that the shear forces is positive 0.75 on acting on B. And then we also have to see the total moment on acting on the beam, which is sigma moment equals to 0. So the moment, we have the M moment itself on the B, which is acting on the positive direction, and also we have the 0.75 forces also contributing to the moment, and it's acting on the negative direction, and we are also going to multiply it by X, which is the perpendicular length of the force, so we can produce the moment out of it. So from there we know that we have two moments, and then we can put it onto the formula. So we have positive M on the B area is subtracted by the 0.75 moment. So it's the moment subtracted by 0.75 multiplied by X equal to 0. So we know that the moment is 0.75 multiplied by X kilonewtons per times meter. And from there, we already have our shear force and also the moment force acting on section A and B. Let's move on to the section BC. So I've also drawn the the free body diagram there. And yeah, so we don't really know what's the length of the A to C total, which on this case we are going to correlate it with the shear and also moment diagram. So we're going to use the notation of X to notate the length. So as the same, we also still have the force on the A part, which is 0.75 newtons, and also here we have the union force acting on the BC part, which is 1.5 kilonewtons per meter. So here, with all of those forces acting, we can directly put it into the Newton calculations. From this case, we are going to count the total forces on the y-axis equals to 0. So on the y-axis, we have 0.75, and also we have 1.5 kilonewtons multiplied by x minus 2. So x minus 2, because you know that the AB part there, we can say that it's 2 meters on this case. And we are going to find the length between B and C, which is x minus 2. So 1.5 kilonewtons multiplied by its perpendicular length, so 1.5 kilonewtons will be multiplied by x minus 2, because we are going to find the area of the rectangle to find the resultant of that force. So yeah, we found that we will find the resultant from that force. Okay, so that's for the resultant, and also we have negative V, which is the shear force acting on point C at this case. So yeah, we have the V on the negative direction on point C, and also we have the M, or the moment force on point C, which is going to the positive direction. So there we have that 0.75 subtracted by the negatively direction resultant force 1.5 multiplied by x minus 2, the length, and also subtracted by V on the negative direction. So we have the shear is 3.75 subtracted by 1.5 x kilonewtons. Okay, now next let's move on determining the motion force, which is we can put it that this is a an object in equilibrium. So yeah, that's why all of the rotations are equal to zero. So now yeah, the moment is equal to zero, and then we have the positive moment on point C on the positive direction, so we're going to notate it at positive. And also we have 1.5 subtracted by 2 multiplied by x minus 2 square, which is the moment on finding the from the resultant of the unified force acting on BC. And also we have 0.75 multiplied by x on the A part, which is going to the negative direction of the motion. So that's also noted at negative, and it's all equal to 0. So yeah, m plus 1.5 out of 2 multiplied by x minus 2 on square, subtracted by 0.75 x equals to 0. So then we found out that m equals to minus 0.75 x squared plus 3.75 x minus 3 kilonewtons per meter. So we are going to create the graph out of this quadratic formula. And also the goes same for the v. We're going to create the shear graph based on the formula of the v on this whole section. You can see that we have the final graph of the shear and moment forces. So for the shear, it starts at 0.75 and it turns down when the unified motion is started to acting on BC, and it goes down until the fourth meter length of the shear. Of the beam. And then yeah, it's based on the formula, and it also goes same for the moment, where it's also goes same for the formula. So that's all from what I can say today. Thank you, and I hope it helps.